Okay, so we're going to do things a little bit out of order. I wanted to do some of the absolute value ones so that you could work with that a little bit. We're going to do 52 first because it's actually simpler than number 51. So in number 52 we have to find the limit as x goes to 6 of the absolute value of x minus 6. So we try out direct substitution. We say 6 minus 6, and the absolute, that's 0, so the absolute value of 0 is 0. So we want to know whether or not the limit is equal to 0 or not, so we put our little question mark there. So we have to find a delta such that if x is no more than delta away from 6, then our function values will be no more than epsilon away from 0. So if we simplify this a little bit, right, we can just get rid of this 0. And the absolute value of an absolute value is kind of repetitive, right? So we don't really need it. So if I take an absolute value of a negative number, I'll get out a positive number. If I take an absolute value of a positive number, I'll just get out that number again. So I know that whatever I get out of the first absolute value, the inner absolute value function, is going to already be positive, so that's going to be whatever this is. So I can drop this repetition of the function there. This is the same quantity of, we know that this will be less than whatever delta that it is that we choose. So if we choose a delta equal to epsilon, it will guarantee that our function itself will always be contained, or won't ever be a distance more than epsilon away. So our box turns out again to be a square, right, where the height is always equal to the width. Okay, what about something where this doesn't appear so nicely? Well, that is in problem number 51. So this time, instead of going to a number where the absolute value works out to be 0, we go to the limit as x goes to negative 5 of the absolute value of x minus 5. So if we directly substitute negative 5 in for x, we get negative 5 minus 5, which is negative 10, and take the absolute value of negative 10, and you get 10. So we need to find some delta such that if such that if x is no more than delta away from negative 5, again we know that this can be written like this, absolute value of x minus negative 5, then our function will be no more than a value of epsilon away from 10. So one way that we can do this, that shouldn't be there, I need my draw. Okay. One way that we can do this is we need to simplify this out. So this means that we have an absolute value. Now we can't just drop this absolute value sign, because let's say x was negative 1, right? Or let's say let's say negative 1. Then we would take negative 1 minus 5 and we could get out negative 6, and this would become 6. But if x was, let's say, 6, right, we would get 6 minus 5, and that would be equal to 1 as well. The point being that we would get different values if x minus 5 was greater than 0, or if x minus 5 was less than 0. But we can control what the value of delta is. So let's assume for a minute that it is less than or equal to 1. That means that we are somewhere on an interval of negative 6 to negative 5. Now if we use the definition of an absolute value function, where if we're taking the absolute value of a, and a is less than 0, then we would just multiply it by a negative 1. If it was greater than 0, we would just multiply it by, we wouldn't do anything to it. We would just return out whatever that quantity was itself. But on a interval of negative 6 to 5, the absolute, or x minus 5 is always going to be some negative quantity, right? If I have negative 6 in here, it'll become negative 11. If I have negative 5 in here, it'll become negative 10. And if x is anything else between that, it's just anything between negative 11 and negative 10. So, using this definition of an absolute value function, I can just replace x minus 5 with the negative of x minus 5. So, the absolute value of x minus 5 minus 10 becomes the absolute value of negative quantity x minus 5 and quantity minus 10. Distribute this negative, right? And I get negative x minus 5. I can factor out a negative 1 from the first and second term here. I can bring this this negative 1 out of the absolute value by just taking, because this would be equal to negative 1 times x plus 5. And the absolute value of negative 1 is just 1. So the absolute value of negative x minus 5 is actually equal to the absolute value of x plus 5. This is the width of our box. And we have control over it, right? So if we said that epsilon was equal to delta, we would guarantee that our function is completely contained within the box. So again, our height is equal to our width, and we get squares, right? Okay. So that's number 51.